I want to talk a little bit about cloud optimized silicon. This is something that Marvell landed. I think the story landed really well on that uptick. And right now, though, as we sort of go into this AI boom, everyone's focused, I've said it a few times here, GPUs,
Right.
GPUs. And I have to imagine for a few reasons. One is we're going to want to do more with less at some point. And the GPUs are great for, large unknown, big sets of data, but as you start to know your problem, whether it's been Meta or Google, you start seeing, or AWS, they're all starting to build custom silicon for, an ASIC, Chris. This is something you do really well. How big of an opportunity is the cloud optimized silicon as it relates to AI? And is this something that the market is also maybe underestimating, or does it just need more time to become sort of front and center?
Sure. It's a very exciting space right now, first and foremost. In terms of the market understanding or estimate the future is unknown, and there's massive amounts of innovation that's enabled right now in this particular side of the market, which is really exciting, I think, if you're in silicon, because there isn't just one way of doing it, and we're just sort of fighting for share. Actually, there's going to be all kinds of new innovations in this space, and new innovations drive new value. So within the computing itself, so Marvell, as you mentioned, launched our cloud optimized silicon portfolio, which is basically the ability to build custom compute capabilities in particular for a lot of these big hyperscale data center operators. And you mentioned announcements of various companies that are doing that. Now, first of all, why would they do that? So ultimately, the way I look at this is, first, why aren't we doing training on CPUs? Because CPUs were built for the broadest possible set of applications. Whether you're running an ERP system or a machine learning, it's a very different set of applications, but they can both do it, just not as well. Mm-hmm. So CPUs, if you think about it as the broadest set of applications that it can run well, but not great, then a GPU is able to do, especially a GPU, a general purpose GPU, is able to run these AI workloads much better. But still, if you're designing a general purpose GPU, you need to be able to design that for the widest set of AI workloads, whether it's a self-driving car or a search engine or a recommendation engine or an image search, there's natural language processing. These are all different applications that you need to be able to run really well. So ultimately what that enables is for individual hyperscale data center operators to be able to build solutions that will solve a smaller set of problems much, much better. So you can do that either for your internal workloads that you have, some of the ones that you mentioned, where they know the application really well, they can build a much better solution, or even as a cloud operator to be able to offer differentiated capabilities to your customers when you're bidding for these cloud services amongst the enterprises that I mentioned earlier, to have a differentiated capability in addition to the standard capability can be a unique opportunity and a value proposition for these operators. And so that's why they would do it. And you're right. We set this company up to do this, right? We acquired Avera Semiconductor from Global Foundries, which was originally part of the IBM Microelectronics division that built chips for decades for other infrastructure companies. And we took that, at the time we acquired the company, they were primarily focused on 5G. And we pointed that entirely towards the cloud and this cloud optimized silicon opportunity to become the partner for cloud optimized silicon. And yeah, it's grown a lot. We outlined a couple of years ago that was an opportunity that for designs we already won. I think this was our 2021 Investor Day, that we had about an $800 million peak revenue designs won. At that time, the total lifetime revenue of those wins were only about 20% were AI. And now more than half of that is AI, just because of how much AI has grown. So yeah, we're really excited about the cloud optimized silicon opportunity generally, but specifically, I think for AI, it unlocks the ability for us to really play a stronger role in compute and adding new and innovative differentiated value above and beyond what's already possible.
Yeah, I think the economics are interesting though, Chris, because when companies do figure out those killer apps, like the ones I mentioned, you can create a lot of efficiencies. The second is going to be power. And no one, we haven't talked a lot about it, and I won't ask you to belabor it too much, but all these GPUs and all these giant clusters, they're power hungry. And so some of this cloud optimized silicon, though, gives you the opportunity to, when you know the specifics of the workload and what you're trying to do, you can, get more efficiency out of the compute, lower power. That's going to be a story, because if we keep growing this utilization, if every person on the planet is using ChatGPT and Bard and using all these all day long, we're going to see the data center power consumption go from a little over 1% to 2 to 4 to 5. This could be massive, and we do have a fiduciary responsibility to the planet at some point, and I think this is something cloud optimized could potentially help with too. Yeah.
Yeah, I think that I mean, that's one of the key parts of the story. We often talk about cost, but remember, if you're selling cloud computing services, you're not selling chips. You're selling an overall service and power, the power that it costs. You have to build a data center, you have to power the data center. That becomes a major, major part of the total cost. So to the extent that we can build solutions that reduce the power for the same sets of capabilities, it costs less, but also is better for the planet, as you mentioned. And so it's a huge, huge focus, not just of our cloud optimized silicon, but of everything. Even in our DSP technology, it's one of our primary focuses and that's why we're staying on the cutting edge, by the way. Marvell announced the products that we've announced today are in 5 nanometer, our 1.6 terabit solutions in 5 nanometer. We've already announced our latest generation in 3 nanometer set of solutions that we're sampling as well. And ultimately, you're going to see that to become a huge focus. Why do you keep moving to the next generation, right? Because you can get lower power. It's not just about performance. It's performance in an envelope, performance in a die size or a power envelope that you can deliver. And I think there's a huge opportunity to improve the overall performance per power utilization.